So in this video we're going to really look at the first equation for those bank of radian equations and formulas that we came across, and they all stemmed, we're seeing, from the basic proof of what a radian is. And here in our diagram we're going to look at the application of the arc length. Now we see the arc length is this here, denoted by S. We have a radius, two radiuses, and ultimately subtended by theta here, an angle. Now we're asked to find or if S equals 7.5 centimeters and theta equals 33 degrees. Now we know our first equation. We know it's S equals or theta. We know that S is the arc length and or is the radius and theta is that angle that's created. From what we're given here on the side, we know S equals 7.5 centimeters. We don't know what R is. We're trying to find that. And we know that theta is 33 degrees. But we must also remember that because this formula came from that radian definition, we can only use this formula if theta is in radians. It'll only work for us. So therefore we must convert the 33 degrees into radians, and we can do that through the X conversion method that we've seen before. To do that, it's very simple. We can convert from any two things, it happens to be radians to degrees here, and what we do is we just need to know one true relationship between them. We know that pi radians equals 180 degrees. So then we can say, well, how many? We can say how many radians does 33 degrees equal? What we do is we draw an X between them. The two numbers that link up, we multiply. So pi by 33, and you divide it by the number that links to the question mark. When you do that, it will work out at 0.58 radians, and we can use that little C for the symbol, or indeed sometimes the little C can be hard to make out, it gets confused with a degree symbol. We can just put down rads. So now we have our angle in radians. We know our arc length, we want to find R. Well, our formula isn't rearranged, so we must rearrange that to find R. So we say, well, if S equals R theta, then R must equal S divided by theta, bringing that theta across. S is 7.5 centimeters, theta is 0.58 radians. You work that out, you get approximately 13.02 centimeters. Being sure to give the units centimeters because our initial question was given in centimeters, and that's how we worked out the radius. So our value for our radius in here is roughly 13 centimeters. That occupied with an angle of 33 degrees or 0.58 radians will give you an arc length of 7.5 centimeters. So once you know two of those values, there's three variables in here. Once you know two of them, you can find out the other. And yeah, that's pretty much it. We also seen the conversion method here.